In this example, we're going to find an equation of the tangent line to the graph of f of x equal to negative 1 over x at the following points. First, the point 1, 2. Now, one thing I want to point out here is we are finding an equation of a tangent line. Now, we know how to find the equation of a line. Recall that to find the equation of a line, we're coming up with the equation y equals mx plus b. We've used that before. In order to write the equation of a line, we need a slope, m, and we need the y-intercept, b. So this is in slope-intercept form. We also have point-slope form for the equation of a line. Now that looks like y minus y1 equal to m times x minus x1. This is point-slope form for the equation of a line, where m is our slope, and then x1 and y1 is a point on the line. Now in your notes, you may find this equation expressed slightly differently, and it looks like y minus f of a equal to f prime of a times x minus a. In this case, we're using f prime of a to represent the slope, and our point on the line is the point a comma f of a. Okay. Notice though that this form looks very similar to point-slope form. We're just using slightly different notation to represent our point and our slope. Either three of these equations can be used to find our equation of the tangent line. But first, what we have to find is the slope. No matter which representation you use to find the equation, we have to find the slope of that tangent line. So to find the derivative, I need to take the limit of the difference quotient. So first I'm going to begin by calculating the difference quotient. So f of x plus h minus f of x all divided by h. I'm going to work on simplifying that. So first, plugging x plus h into the function, we're going to have a negative 1 divided by x plus h. Then I'm going to subtract from that f of x. So subtract from that a negative 1 over x, and that's all divided by h. So now we need to work on simplifying this. So let's get a common denominator in the numerator there. The common denominator is going to be x times x plus h. So I'm going to multiply the first fraction by x over x, and then the second fraction, I'm going to multiply that one by an x plus h over x plus h. And then keep in mind this is all over h. So now simplifying that, we're going to have a common denominator in the numerator there of x times an x plus h. And then subtracting the numerators, a negative x plus an x plus h. And then keep in mind this is still all over h. Now notice that we have a negative x and then a positive x on top there. So those are going to cancel. So we're going to be left with an h divided by x times x plus h. And then this is all divided by an h, but instead of writing it as divided by h, I'm going to write this as multiplying by 1 over h. Now notice here we're going to have h in the numerator, h in the denominator are going to cancel, so we're left with a 1 over x times x plus h. So there's our simplified difference quotient. Now to get the derivative, we have to take the limit of this. So we have the limit as h approaches 0 of our difference quotient, 1 over x times x plus h. And as h approaches 0, as h gets really small, we can think of it as going to 0. Then what we're left with here is a 1 over x times x, or x squared. So that gives us our derivative. Our f prime of x is equal to 1 over x squared. Okay? And then this derivative will give us the slope of the tangent line at a given x value. Well, we're interested in what the slope is at x equal to 1, because that's our point. Our point is 1, 2. So we want to know what the slope is at x equal 1. So now taking f prime of 1, we have 1 over 1 squared, which gives us 1. So the slope of the tangent line at x equal 1 is 1. So now that we have the slope of our tangent line, we can write our equation. We have our slope, we have a point, we're set to write our equation. So I'm going to use this bottom equation here, plugging in f of a. In this case, f of a is 2 from our point. Our point is 1, 2. So f of a in this case is 2 equals, we have our slope now, we found that to be 1, times x minus a, in this case is 1 from our point. Now it's a matter of simplifying this. So we have y minus 2 equals an x minus 1. Adding 2 to both sides, we have an x plus 1. So there is our equation, y equals x plus 1, the equation of our tangent line. In this case, I used point-slope form to find the equation. You could, however, use the y equals mx plus b, slope-intercept form. And to use this, we have our slope, we found our slope to be 1, so plugging that in, we have 1x plus b. Now what we need is our y-intercept. Well, we have a point, 1, 2, plug that in for x and y. So 2 equals 1 times 1 plus b. Now we can solve for the y-intercept. So we have 2 equals 1 plus b. Subtract 1 from both sides, and we have that the y-intercept is 1. Now we can go back and plug that in to our equation. Y equals a 1x plus 1. And there we have our equation. Now for part B, we're going to find the equation of the tangent line to the graph of f of x at the point 2, negative 1/2. Now recall we found the derivative f prime of x to be 1 over x squared. So now we want to use this derivative to find the slope at x equal 2. So plugging 2 into the function f of x, we're going to have 1 over 2 squared, which is going to give us 1/4. So now to write our equation of the tangent line, we can think of our point 2, 1/2 as a, f of a, and then plugging everything into our equation here to come up with our line. We have y minus f of a, in this case, our function value is a negative 1/2, equal to, we found our derivative at 2 to be 1/4, times x minus a, in this case is 2. So now let's simplify this. We have y plus 1/2 equal to 1/4 x minus 1/2. Now subtract 1/2 from both sides. Y equal to 1/4 x minus 1. So there's our equation of our tangent line. If you prefer to use slope-intercept form, y equal mx plus b, you can use that form instead. In this case, we found our slope to be 1/4, so plug 1/4 in for our slope. Now what we're missing for our equation is our b value, our y-intercept. We'll plug our point in for x and y, so we have a negative 1/2 equal to 1/4 times 2 plus b. So we have 1/2 equal to a 1/2 plus b. To solve for b, subtract 1/2 from both sides, and we have b equal to a negative 1. Now we can go back and plug our b value into our equation, y equal 1/4 x minus 1. You can use either method you choose. And there we have our equation of the tangent line at the point 2, negative 1/2. Next, what I would like to do is point out something about this function f of x equal to negative 1 over x. Notice that for x equal to 0, the function does not exist. We can't plug 0 in for x. Therefore, we can't evaluate the difference quotient at x equal to 0. Therefore, the derivative f prime of 0 does not exist. So we say in this case that f is not differentiable at 0. So when a function is not defined at a point, then it is not differentiable at that point. And in general, if a function is discontinuous at a point, it is not differentiable at that point.